I'm not hearing anybody go, ugh, so we're good. Hopefully. If you're vomiting, vomit in Dynasty or not here. That one got a laugh. Okay, good. I had an audience the other day of 100 people. Nobody laughed at a single joke I made. It's very sad. It's just a good sign that says I'm totally funny, they just didn't understand, right? So, humanity, as a whole, has been around for about 160,000 years. We've explored the surface of this world, we have changed it. One big discovery of humanity is tools. Every single aspect of this world, every bit and piece and part can be made into something else, something useful, something that can change our world. As we developed tools, we would develop societies all across the world, and one of the most common elements of every society, definitely when they're first starting, is the campfire at the end of the day. After working really hard on whatever part of job of society that you have, you would end up putting your tools down and going to sit around a campfire. In some places it was for warmth, some places it was for cooking, others it was for keeping bugs away with the smoke. But people would gather around those fires. And as they would do so, they do exactly what everybody loves doing, gossip. They talk, and talk, and talk, and talk. My mother's worst nightmare. Me talking forever. But as people talk, they communicate, they tell us stories, they share them. And because they're around a campfire at night, when they get the best chance to talk, everything around them became attached to those stories. There is a reason why when you go out camping, you tell campfire stories, because it is something humans have always done. But at the same time as telling stories, we would also have a chance to see our skies. The vast, empty darkness of the universe splits by tiny pinpricks of light, would become attached to the stories we would share. And about 5,000 years ago, the most famous set was invented. The Greco-Roman scientific standard of constellations is incredibly well known. It's the one talked about most in the world. It is not the first set of constellations, not the most recent set of constellations. It's just one through happenstance of history we talk about the most. They feature stories about gods and monsters, mythical creatures, and men and women heroes who use their intelligence, perseverance, and strength to save the day. Over towards our northwestern sky, barely above the horizon, is the square who's flexing both of his arms and legs because he proves he never skips leg day. Hercules. Hercules is the son. One person found that funny. That was good. Hercules is the son of Zeus and humanity. He fought for humans against monsters his entire life. He fought for the realm of gods against other gods as well. And so when he finally died, the gods gave him a gift. They took his soul out from the underworld and placed it among the stars, so that in the future we could remind ourselves his muscles looked really good. There are other stories in our sky we might not expect. If you are around my age, mid-late 20s, you will have been raised during the age of Disney. And you're also bankrupt because Disney Plus. Oh my gosh. I could not. It's Disney. It's great. But if you were raised in the age of Disney, or if you really like Disney movies, guess what? They are total rip-offs of our sky. Every single movie that has been made by Disney that was not made with Pixar's help is actually a rewriting of a story from ancient times. For instance, one of the most famous, the one that I absolutely hate because my sister would not stop watching it every single day till the VHS tape wore out. And by wore out, I mean I threw it in the trash. We have the upside-down house-like shape of King Cepheus, a sideways W shape of Queen Cassiopeia, and an upside-down V-like shape of Princess Andromeda, king, queen, and princess sitting on their thrones in an ancient kingdom. These three were the main core of a story. There is also included in this story a kind of claw, hands-reaching like shape of the hero named Perseus. Perseus himself is just below Andromeda. He's kind of reaching to save her. He shows up for about 5 minutes and leaves, which is almost the same in the Disney story, though he gets called the hero. How interesting. In this Greek version of the story, Cepheus had his wife, the queen, who was not Cassiopeia. They ruled for a very long time in peace and happiness. Eventually, they became pregnant and had a daughter. And soon after, the queen died. Cepheus, now having a brand new daughter to raise and a kingdom to rule, decided to choose one to spend all of his efforts on. He chose his daughter. So he married someone who could be a queen and rule the kingdom properly. The best option was Cassiopeia. Cassiopeia had a lot of flaws. she wasn't the best of people. She was a warmonger. Basically, if her people had a problem, she did everything she could to help them with that problem, usually by going to war. They'd say, hey, we're a little low on food, and she says, our neighbors aren't. To war. Hey, we actually have too much food. Our neighbors don't have enough. To war. For what reason? To give them food with war. I don't know. She liked warfare. She was a tactical queen, and she was brutal. She would basically start wars with anyone for any reason. She was amazing at it. No one ever came even close to beating her at warfare. And the reason is because of a magical item she has. And this magical item kind of gives away what the story is. This magical item was given to her by the god Apollo. Apollo is the god who drives the sun chariots across the sky each and every day, which actually quite literally means that's his day job. He also, though, is the inventor of music. He was 2 minutes old when he made the first ever harp. He played it. And when he did, the music was so beautiful, the world was silent, listening to him play. And 7 goddesses, the 7 goddesses of fate, the ones who decide what will happen in the future, said, as long as you are playing your music, we will tell you fate. We will tell you the future. Cassiopeia had a magical item that used sunlight, music, and told her the future. It was a mirror that reflected sunlight. She sang a song to, and it would tell her what would happen next. This song, translated in English for the Disney story, is very simple. It's a poem. Mirror, mirror on the wall. This is Snow White, after all. The Disney story and the Greek story are slightly different, because Disney has done what every storyteller does, what I do, which is take the elements of the story that they like the best, the elements that would make most sense to their audience and their media, and they tell them. I am an educator in the middle of a museum. I'm not a movie maker making 2-hour-long movies for children, so my stories are slightly different from theirs. Name a Disney movie, and as long as it doesn't have Pixar on it, because Pixar's actually creative, they have managed to change it just enough not to get sued for copyright. Or at least that's the idea. That's not actually a bad thing, by the way, them changing the stories from ancient times. It's just interesting, but they don't ever seem to mention it. Story after story was placed among our skies, but there's a second set of shapes you know two in, but you don't actually know the shapes most of the time. They're called asterisms. Asterisms are usually brighter, easy-to-find shapes in our sky that instead of being stories are actually more along the lines of tools. Tools that can tell us things like the seasons. In our sky, almost above our head, we have, not above our head, sorry, towards our left side as we see it now, towards our west, we're going to have a triangular shape above our horizon. Made of 3 of the brightest stars in our early nighttime sky, this is known as the summer triangle. It is up primarily during the summer, leading into winter. Another side, exactly on the opposite side of our sky, towards your right, we have the first star, Betelgeuse, the shoulder of Orion, which makes up another triangular shape you'll be able to see in a little bit. 2 triangular shapes, one for summer, one for winter, tell the seasons very easily, very useful for farmers and other such. A more seasonally appropriate shape would be the autumn square. The autumn square is in between, of course, summer and winter, and so it shares a star with the head of Andromeda. These shapes are bright, easy to see, easy to find, simple, and they just tell us some basic information. We know what season it is usually, but sometimes we want to make sure it's not getting late in a season, definitely if we're an early agricultural society. But the shapes you know of the asterisms, the 2 shapes you know in the asterism sets, are going to be the Big and Little Dipper. The Big Dipper is just barely above our northern horizon tonight. I don't recommend looking for it unless you have a very flat area to look for. Basically nowhere where there's a house, a hill, a mountain, or anything like that. But the Big Dipper itself to the north is incredibly important for a lot of reasons. There's a reason why everyone knows it, even if they don't know that much about it. The Big Dipper is a signpost in our sky. It points us in the general direction of many things, many different shapes and constellations, but most notably its companion asterism, the Little Dipper. I wish I would have known about this when I was little so that I can win every argument against my sister, but if you use these 2 stars here, you can extend the line to the next brightest star and find the tail end of the Little Dipper. It's actually designed, specifically, the Big Dipper is designed to help us find the Little Dipper. The Little Dipper's asterism purpose is navigation of the world. It's to help you find out where you are with the star known as Polaris. Most of you probably know it better as the North Star. Now, a lot of movies get this star wrong. It is not a star that is significantly different than any other star. It's not the brightest star in our sky by far. It's 47th brightest, which means it's exactly equal to New Mexico in public education standards. That one worked. You should have seen when I had an entire audience of homeschool parents. They loved it. It was great. But this star is not significantly bright compared to others. This star is special, not by difference, not by brightness. It's special by location. It's a good life lesson, in fact. Sometimes you don't have to be smarter or different than anyone else. Sometimes the best thing you can be is present at the right place at the right time. But this star doesn't seem to be just in the right location. It seems to be nearly pinpoint perfect. If you watch through time, let's take a couple minutes, an hour, and about 30 seconds. As the Earth begins to spin, the stars rise and set. The sun and moon move around and rise and set because the Earth is spinning. And as it spins, just like any spinning object, a CD, DVD, or record, which I was informed kids have no idea about anymore, which is sad, it makes me feel old. But anything that spins has a center point of spin. So that CD in the player is held onto the machine by the center. A Ferris wheel is held onto the ground, not by its edges, but by its center. When they give you the stick to break the piñata and you're expected to get dizzy, you put the stick in the ground, your head to the stick, and you start spinning. There is a center point. The stick doesn't move in the ground. Nothing moves at that center point. And just like the Earth, as it spins, it has the north-south axis. And the stars rise and set, but Polaris barely moves at all throughout the entire night. Sorry for that. Throughout this night, we have this star always there, this high above our horizon. And actually, it doesn't matter when you look for this star. If you could somehow see this star at any point in time, whether it be weather conditions, whether it be daytime, this star will always be there for the rest of your life. This star does move, but not significantly enough that you would notice with just your eyes. You would need technology. The only time we ever see this star move is when we have moved. If we move farther towards the north, this star rises. If we move further towards the south, this star sets. It tells us exactly where home is. Very useful. This star allows the Vikings to explore their entire continent, find new places to invade, ally, or live. This star allowed the Samoan culture to explore the vast empty oceans and find the islands they called home, including the well-known Hawaii. This star allows your Amazon packages to arrive 3 days after Christmas. Because even though they're still using these stars to navigate, it's slow, it's oceans. But as we have gone through time, we have learned more. And asterisms are just part of it. We have learned about our universe and explored it. The most common set of constellations I get asked about during this show is the set known as the zodiac. This is a set of 12 that make a ring around the Earth. The reason why I get asked about them usually has to do with the horoscope. It's a belief system based upon the constellations along the zodiac, very similar to the Greek and Roman stories based on, that the constellations are based on. However, this belief system didn't originate the shapes, they originated from the shapes. So they're much younger of a belief system. The horoscope basically, and to put it very simply, has to do with time. As the Earth orbits around the sun, we actually notice the sun appearing to move across the sky. This appearance of motion takes the sun from one day to another, from one blue dot to another. And as the Earth moves slowly around the sun appears to be in a different place among the stars. And as the sun moves, it tells us the year, which is great. The only problem is there are other points of light that move like the sun do, namely the planets. If you're planet hunting tonight, have fun with that. Planet hunting is ridiculously terrible right now. If you want to hunt for planets, get out before sunset, look to where sunset is. You're going to find Venus. Venus is barely above our horizon. It's going to set in about 2.5 hours. It's an extremely bright point of light. It is the brightest point of light we will have in our sky while it is up. And that's it. Uranus and Neptune are both going to technically be up above your head. You could see them really great if you had eyes of a god. We didn't even know Uranus and Neptune existed until hundreds of thousands of years into our existence. And specifically, it's because we need telescopes to see them. Uranus was discovered in the late 1700s by telescopes. We didn't even know it was there until we accidentally found it. Neptune was found in the early 1800s because it's so far away that it's even hard to find with telescopes. We had to find it using mathematics, otherwise known as Planet X. There are Planet X's all around us. They're usually comets and asteroids. It's basically any time we use math to find something using gravity. Excuse me. But as people would watch the sun move across the zodiac, they would watch the planets as well. And planets are actually the reason why zodiac is called zodiac. If you didn't know, zodiac is Latin, a dead language. You can learn a little bit of a dead language today. It means God contains a star, otherwise known as the constellations that contain or hold the Roman gods, or planets, named after them. The motions of the planets across the sky are very odd, and they don't follow a specific pattern like the sun does. And so, in order to explain their pattern, we use other methods. We came up with an idea. And that's how the belief system of the horoscope came to be. If you're wondering why I'm going over this so in depth, you trust me, I get asked this so much. It's ridiculous. But we have done more. We're not just a tool-making society anymore, we are also engineers. We use the tools to make more tools, to make more tools, to make tools that make tools for us. It's very complicated. But engineering in general has allowed us to explore our world, allowed us to learn so many things we never even thought possible. And we added to our sky. Something our ancestors would never see, and would never have been able to see because it was physically impossible because they didn't exist yet. Satellites. A little bit over 75 years ago, we first got out into space with rocketry. It took a couple of years after that for us to send the first satellite of Sputnik 1. And ever since Sputnik 1, we've sent 9,000 satellites in total in the last 75 years. 4,000 are still active doing science, and there are 10,000 planned in the next decade. We are aggressively expanding our satellite development. Satellites themselves, most of the ones we can see, move from one horizon to another. Most people have actually seen them if they thought they've seen a meteorite. Meteor showers do happen, they're fairly common, but they start in a center point of our sky and move and burn before they reach the horizon. Most of the time, if you see something go from one horizon to another, that is a satellite in itself. And when we got into space, we got to actually look at humanity. A good, proper look. Not just because of our lights, because our lights are pretty revealing. They tell us where we live, sure, but they also reveal more details than we expect. Of course, we do get to see the size of cities, and we get to see areas where people live extensively. That makes a lot of sense, but we learn insights into how people think, such as, oh my gosh, it's cold, no way. It's a very good thought. It's cold up there. We don't live in the cold as much because we're not a species designed for it. We do have Anchorage up there. They live up there, but very few people live in the cold. We also learned that Florida is terrible in the center. I have no idea why, but the evidence supports me. Nobody lives there. I'm kidding. If you're from Florida, I'm just joking. I'm sorry. We get to see more than just where we live. As well, we get to see our motion. These lines you see across the United States are our major interstates, our major highways, how we move. And of course, this is Mexico, you didn't know. But as we move along, we build along those paths of motion. And so we get to see how we interconnect, how one road leads to another. There's also, of course, a proof of the difference. There's actually a split in the United States. You might be able to see a kind of an emptier side and a more dense side of lights. That split is a well-known river named the Mississippi. On one side, we have a lot more land that is more suitable for agriculture, our side. And the other side, we have one that is less so. So the farmland is split into smaller sections with more lights in between. Oh yeah, and you and I. In New Mexico, we're in this darkened space. New Mexico has some of the best skies in the United States, second best, beat only by Alaska, but we don't freeze, so we win. And we have some of the best. I mean, we have 6 international night sky parks out of 15 in the United States. International night sky parks are specifically designed to give you perfect night sky. I'm about to try to chase this sunset. Oh my, sunrise. So with the International Night Sky Parks, we get to see our skies clearer than most places ever get to see in their life. We have our first ever in the world urban night sky park here, meaning it's close by to cities, but still able to see the stars as clearly as possible. Albuquerque is extremely bright. We can see it, but just above Albuquerque, we have 3 points of light. Santa Fe, Los Alamos, and Espanola. It's fantastic. Big cities, you can see them. But in between them, there's this small point of light, and I didn't win. Pause time. I tried to beat the light, and I lost. Okay, so in between these 3 cities, there's this small point of light. This point of light, most of you have driven through if you have gone from any one of these 3 cities, Santa Fe, Los Alamos, and Espanola, to any one of the others. This intersection is where City's Gold is. It's also where I was raised, the Pueblo of Oaxaca. 900 people voted in the last election, so you know, big town. 2,000 people live there in total. 2,000 people can produce enough light to be seen from space, and we're pretty bright compared to some other places. It only takes a couple hundred people to produce enough light to project into the universe. I love that idea because some people think there are billions of humans, I can't make an impact. Yeah, you can. Turn on your lights and be horrible to your neighbors. And you can be seen from space. It's pretty awesome. Now, satellites were just one small part of when we first started going into space. 25 years after our first satellites, we sent people to the moon. 50 years ago this year, we sent people to the moon first with Apollo 11, several months ago and 50 years ago, and then Apollo 12 about a month ago, its 50th anniversary. When we stepped foot on the moon, we traveled a distance greater than the diameter of every other planet in our stellar system. We stepped foot on the moon. We proved that we could exist on 2 celestial objects. We proved that our technology, though terrible and rickety at the time, is still strong enough to get us out, to allow us to explore the universe we call home and we live in. We brought lunar rocks back that we still study today, including one chosen for this museum, an Apollo 17. Apollo 17, the last mission to the moon, had the first ever and only scientist on the moon. Everybody else who had ever landed on the moon, all the other astronauts, were either pilots or engineers. This was the first geologist, the only geologist. His name was Harrison Schmitt. He was a Republican state senator for New Mexico for a time. And when he was on the moon, he picked up a lunar rock and said, I want this one sent to my museum. This lunar rock is available for public viewing here today, and also, not to brag, but it's quite large in the fact that it is the largest lunar rock available for public viewing in the world by a magnitude of 10. Wow. So it's 10 times bigger than almost any other lunar rock in the world. So, just saying, ours is bigger. Makes us better than the Smithsonian, right? No, I'm kidding. Smithsonian's obviously better, they're more expensive. When we went to the moon, we explored. And right now, we're going back. 50 years ago, we went to the moon because of politics and economics. Now we're going to the moon because of science. Our technology we invented 50 years ago is pushing us to the moon. And so we've got Pakistan, India, Serbia, China, Russia, and the United States, independently with their own with their own nationwide space programs going to the moon. China landed its first rover on the moon in the first day of 2019. India attempted its first landing and failed, just like literally everybody has always done. NASA failed 5 times, Russia failed 22. Ha, we win. Sorry. But we are going to the moon again. Most countries that I've named work together as well in the European Space Agency. A dozen or so smaller countries work with that primarily to get people to space, to the moon, to do research. Most places have a 10-year mission plan to have people on the moon. In a decade, you might be sitting in this museum watching a live stream in 4K resolution of somebody landing on the moon and saying something not as impressive as the first time. Sorry, I just don't think we're as good as one-liners. And maybe one day, in a decade, maybe 2, maybe 3, we will look to the surface of a new moon, like we have tonight. We will not be able to see the moon tonight. It is right next to where the sun is, and so it will set at the same time. But when we look at a new moon, we can't see the surface lit up because the side in shade is facing us. But instead, in 2 decades, we might look up and see a point of light no brighter than my hometown, where a whole bunch of scientists who wear different flags on their shoulders work together to answer the questions of the moon and the universe. At least that's my home. And it looks like that's where we're going. It'd be pretty fantastic if it did. Only they allowed me to get on his space because of my arches. Dang feet. Some of you got that joke. But we have explored so much.
and we still explore. And so we're reaching my halfway point where we're going to leave it up to you guys. We have sent technology out past the Earth and the Moon to most of our planets. We haven't had long-term visitors around Uranus or Neptune or Pluto, or any one of the further objects, but we have had a few visitors nearby. We've traveled throughout our stellar system, filling in the gaps, going from 6 major planets to 9 to 8 major planets, with 6 dwarf planets. Pluto is reclassified. This happens in science all the time. It's not declassified. A lot of people like to say, why was Pluto declassified? It's not a legal document. Declassification only happens in legal documents. Reclassification happens all the time. And I just have one thing to leave you guys with. If you really hated that Pluto was reclassified, if you're above the age of 25, you as a human have been reclassified twice by human scientists. Take that existential crisis home with you. Well, reclassification happens because we discover new things. We discover and we observe. 6 planets was nothing. We now have 8 major planets, 6 dwarf planets. We have millions of asteroids in the inner asteroid field between Jupiter and Mars, which happens to be where Ceres is. Millions of comets out past Neptune, where Pluto is. You notice the pattern where asteroids and comets are nearby the dwarf planets. That's what they are, and that's why they're there. But we also have 6 other objects called planet X's. We found them with math. Most of them are probably comets. One of them might be a dwarf planet. One of them might be an actual planet. But we haven't seen them with observatories yet, so we just have math saying they're there, which could basically mean they're not there at all because math can be really difficult. For those of you who want to study something in the realm of science and hate math, by the way, this happens a lot of times when people start going to college. No matter what science you choose, they're going to make you take really advanced math. Math is terrible, I say, having studied it for 10 years. Math is horrid. Go get an astronomy degree. Astronomy allows you to have 300% error. And they'll tell you how amazingly close you got. So to put that in perspective, 2 plus 2 can be possibly anywhere between negative 14 and 37. And I'm dead on the money. I literally wrote a paper where I had 356% margin of error, and it was the closest anyone had ever gotten in the world. Granted, it was something nobody cared about, which is why I was close, but just do that. You don't have to be right at all. It's great. But now I think I've given you guys enough time to kind of think about a few ideas. If you're having a hard time, we can talk about favorite planets. We can talk about more constellations that you like. We can talk about galaxies, nebulas, the universe. We can talk about the future of humanity in space. We can talk about storm systems or moons. If I have the knowledge of it, I'd love to share it with what you guys want. So keep in mind, I'm not only blind, I'm not a teacher. If you're raising your hand, I'm never going to call on you. So just feel free to yell it out. Whoever has the loudest lungs wins. So excitable, my audience. Mars. Great. What a great question. Mars. Mars itself is a huge area of study. It's something people have focused on for an incredibly long time, and I hate Mars. Personally, I just don't like Mars. I don't think it's all that interesting, but it can be when you look at the science. So Mars itself is a terrestrial planet just like the Earth. And Mars, Venus, and the Earth are basically 3 sides to a coin. And if you're wondering how are there 3 sides to a coin, the middle, obviously, the coolest flip you'll ever have is when a coin lands in the middle, which is statistically possible. Mars is the end of a timeline. The Earth is the middle, and Venus is the beginning. Mars used to be a lot like the Earth in a ridiculous fashion. We have explored it with satellites, with landers, with rovers, and what we find consistently is that there was a lot of details very, very similar to what we find here now. Namely, ice caps. Ice caps are pretty obvious. Whenever you see anything on the news that says, "We found water on Mars," no duh. We found water on Mars when we first looked at it over 3 centuries ago, in ice. News reports like getting really excited about water on Mars. Scientists are looking for liquid water on Mars. We have found that as well. It's not as exciting, I think, personally. Mars did have a lot of water on its surface, though. We know it disappeared over time. The reason why we know Mars had surface water is because of the largest geographic structure in all of space science. That huge you see right in front of you there, that is Mars's version of a Grand Canyon. This, though, is a lot bigger than ours.
So, despite what they tell you, because that would be California, that would be Manhattan. It is a massive structure. That is half the size of New Mexico. It was cut out by water over millions and millions of years. And we can see very direct evidence of water flowing in deltas and flowing out the other side. Now, it doesn't quite look like our Grand Canyon, because our Grand Canyon snakes around rocks, and that's because of the difference of surface, completely covered in sand and sandstone, instead of kind of split between limestone, sandstone, and several others of the Earth. We do know Mars used to have volcanoes and tectonic activity, motions underneath its surface to build mountains and valleys. We know this because of the largest volcano in all of our solar system. That's known as Olympus Mons. It means big mountain, which it quite literally is. This is about equal to the size of New Mexico in size and about 7 times taller than Everest. It's massive in size. It used to spew out molten lava all the time, but it doesn't anymore. Mars is about 2/3 the size of the Earth, and that's why we think there's such a difference in what Mars used to be and what it is now. Mars used to have an atmosphere thick enough to contain water. If you remove atmosphere, water boils away. That's why if you're in California, where atmosphere pressure is more, you have to turn your temperature up higher to boil water. We get 93 degrees instead of 100 here to boil water if you use in Fahrenheit. Sorry, Celsius. Because Celsius is better than Fahrenheit. Obviously. British use it. It's good science. Right? I mean, granted, they don't use any spices for food, but they conquered the world for them.
What? Was that other plane?
That joke didn't fly. Okay, sorry. But in general, Mars used to have this bigger atmosphere that it lost over time. It was small enough that a few bits of atmosphere started leaving, and over many, many millions, up to billions of years, it lost its atmosphere. The Earth has the same ability to technically lose its atmosphere. We lose 1 atom of atmosphere every half century. So, that breath you just took is about 5 billion years. Atmospheric loss. We don't really lose atmosphere in the Earth because we're big enough. Mars did. We want to study Mars because it shows us a lot about what the Earth could be, what the changes could happen to the Earth. We get to see an environment very similar to the Earth. Some theories about life, by the way, originate on Mars. And not crazy theories like Scientologists. I'm actually talking about realistic theories. One, it's called, actually, you know what? I'm not allowed to say that word, never mind. It's basically the idea that life might have developed on Mars, as Mars kind of seemed to have water cycles more stable earlier on. It was impacted over time by an asteroid, which brought life to the Earth. We know this happens every now and then with the Earth. Early in our history, as life was developing, it would still get impacted by asteroids that would totally obliterate all life on the Earth. But it wouldn't destroy everything because sometimes when an asteroid hits something, it throws out debris into space. This is how both Mars and the Earth ended up with moons. Mars has 2 moons in particular. They're both a lot smaller than ours, but they're debris left over from an impact collision to its northern ice cap. The northern ice cap was hit by a very large asteroid and threw out debris into space. 2 of these bits of debris ended up in orbit as Phobos and Deimos. Some of this debris ended up re-crashing onto Mars. Some of this debris ended up flying out into space, and 1 bit of this debris ended up in this museum. One of the first 7 Martian meteorites ever found, of 300 we found so far in the world, it landed on the Earth, traveling an incredible distance. But sometimes those asteroids, when they got hit on the Earth in history, they would fly up into space, and whatever biology got flash frozen. Some biological life can survive and still live in space. We call them tardigrades. For some reason, Pakistan sent some to the moon 2 months ago. I kid you not, they actually sent things that could survive on the moon. It's very weird. It was an odd thing they did. But Mars might have been an origination point for life. Life might have developed on Mars, got impacted, sent into space, and hit the Earth, and started life here. Or maybe the opposite. Maybe the Earth started life on Mars, but it never took hold because, well, Mars is a little bit too small. We don't know. Over the next couple of years, we have more plans to go to Mars. Elon Musk hates people so much, he wants to go to Mars so badly, his life pushing into it. And we might have people living on Mars fairly soon.
Some of the experiments and research we're doing include tectonic activity. We get to watch as things move. We want to watch a little bit more about the difference in different areas when it comes towards rocky surfaces and features. But they're all kind of in the future. Though I can tell you, my generation is starting to go into science. Because the next planned mission to Mars, the next planned rover, is not a rover, it's a quadcopter. We're sending the quadcopters. We're basically being hipsters in space. But it will work. It's actually better and far superior than the rovers in the sense that the rovers break so fundamentally easily. Now the pictures I'm showing you are of opportunity. I'm basically shamelessly plugging my entire museum today, and I don't mean to, I guess that's what I'm doing. You pass by a working model of the Opportunity rover. You get to move the camera around. It doesn't take samples or anything else, but that's usually the most of what rovers do. It is one of only 2 working models for the public in the world. The other one is in the Smithsonian. They're broke. So we're still winning. Largest lunar rock, best Mars rover. We're awesome here. Smithsonian's got nothing. I'm kidding. Okay. Opportunity explored for 14 years out of a 6-month mission period. You ever been hired for 6 months and then you ended up staying there for 14 years without a pay grade? Hopefully not. Poor Opportunity. Opportunity eventually died, though. It ran out of battery when there was a storm system above Mars. Its dust covered enough of the solar panels that it ran out of charge. A lesson for you guys who use chemical batteries, which means smartphones, laptops, pretty much anything. Don't empty their charge. And don't fill them to max. You want to keep it in between 20 and 80. And the reason why is because when you overcharge, you start burning the cells out. When you undercharge, the electrons stop flowing, and they'll stop flowing forever, which means no charge. Opportunity died because it ran out of power. It used up every bit of juice it had, so it didn't have enough to start charging and get that motion going again. But it conveniently died in the middle of Albuquerque. Quite literally, there's a valley on Mars called Albuquerque. It's right next to Santa Fe Rock, and all the areas in that location are named after the Camino Real. We happen to have Dr. Larry Crumpler work in this museum. He worked with Opportunity. They started using names he suggested from here. It's the first ever non-Anglo naming system in all of space when it comes towards physical features. And also, of course, Opportunity died in Albuquerque. Probably had its tires stolen. I live here, I'm allowed to say that. That's basically Mars. That's the most amount of information I have, other than one newish bit of information. And it has to do with that water thing I mentioned in the very beginning. In its northern ice cap region, that asteroid impact I mentioned, that right to the Earth, that made the 2 moons around Mars, it left a divot. This divot was immediately sealed above. So the ice that was kind of impacted away from this kind of starburst pattern here it refroze where the asteroid made its divot. And so there's ice above a divot, and with radar we actually managed to see liquid water. It's completely encased in this ice, but it's liquid still, which means if there was ever life on Mars, and if there ever could be life on Mars, it would develop there, and it would be there, in its northern ice cap. But that's Mars. And it looks like we still have time, thankfully. I kind of talked a little bit much about Mars. Follow-up questions are always allowed, as well as questions about literally anything else in the universe. As long as I know it, I'd love to share it with you.
Where else could we find life in the solar system?
A little bit louder, the first part.
Where else could we find life in the solar system?
Where else could we find life in the solar system? Astrobiologists could tell you a lot. So if you really, really hate math, and you really, really hate any factual evidence, become an astrobiologist. Astrobiologist is an actual science. You can get a degree in it, but it is the worst science when you want to be definitively sure. Astrobiology is the science of life. We have one sample size, the Earth. Having a sample size of 1 is like saying that everybody loves my mother's cooking, because my mother loves it. Ask the rest of my family, get a sample size of 7. No, we don't. I'm sorry, I'm reeling my mother. She does not make great cooking. She's an amazing baker, horrible cooker. But when it comes to life in our stellar system, we really have to compare to the Earth. We only know about life that developed in the same way the Earth did, which means through amino acids. Amino acids, the building blocks of life, they are not alive.
But when you put them together, they make life. We don't really get the distinction. We haven't quite understood what makes that distinction, but we know amino acids are required. To make an amino acid, all you need is a few chemicals that come from geography, usually. So when rocks push into each other, when the chemicals of stones push into each other, you can get you can get these certain chemicals that when electrocuted or sent with a lot of energy, you can get amino acids. So that basically wipes out all 4 of our gas giants. They can't possibly have life as we know it on their surface. However, their moons might. So the Earth has life, Venus does not. It's too hot, it doesn't have any water. Water is kind of important as well just for human life, though we don't necessarily need water, we just need a liquid media of some kind for basically squishy, movable body parts. I kid you not, that's actually a scientific thing. But when we look at objects that have geography and electricity, we find that moons around Jupiter and Saturn have the possibilities. When it comes to what we look at and what we observe, we usually want to find an ice moon. Icy moons usually have liquid underneath their ice, kind of trapped and encased. Jupiter's was a great idea. We wanted to look at one of its moons that we call Europa. Sorry, I was trying to read it at the same time. Europa. Europa itself is entirely covered in ice. We got to see it with Juno. Juno is the satellite in orbit around Jupiter right now taking pictures. Europa is small, but not significantly small. It's about 75% the size of Mercury, so it's nearly as big as a planet. It orbits around a monumentally sized planet, so it's not really looks like anything. Jupiter's big enough to fit every other planet within it twice. So, massive sized planet it orbits around. This Europa shows us quite a lot of decent details. We've got these cracks in the ice surface. Cracks means terrestrial. It means there's a solid surface under this ice. It's not just a solid ball of ice. Cracks basically means moonquakes. You can't get that without terrestrial surface. And so that's fantastic. We've also found evidence that these cracks spew out a little bit of water. Not a ton, but a little bit. And we managed to take samples from that. And it's saltwater. Great, saltwater ocean, just like the Earth in the very beginning. This looks like a good place to have life. However, there's one problem. This encroaching brown reddish thing. This reddish hue is a mixture of 2 things. One, it is spew off from an actively volcanic moon around Jupiter named Io. It's its close neighbor, and so it spews out basically the most noxious chemicals possible onto its surface. And 2, it's the salts in the ocean. The salts what make up most of its detail. Salt, when placed under a high radioactive environment, turns red. It's a red salt test. They use it when you work with nuclear anything for government research. Salt tests are actually horrible, by the way, because if you walk into a room that has red salt and you work there for weeks, you're probably radiated. It's not a warning, it's a telling you, oh yeah, you're in trouble. Radiated salt. The reason why it was radiated is because Jupiter itself has a magnetic field 56 times stronger than the Earth. A magnetic field is nothing when it's the size of Earth, but when it's strong enough, it can produce not only energy, but radiation of much more monumental magnitude. It is literally called electromagnetic radiation. And yes, I know we just flew through a moon, we're immortal here, don't worry. But Jupiter itself has such a high magnetic field that it would basically rip apart amino acids at first convenience. The best place we have to find life is a moon almost the same, but around Saturn. Saturn doesn't have nearly as strong a magnetic field as Jupiter does. It's a couple of times stronger than the Earth's, but not nearly as significant. It has one moon around it we call Enceladus. That's the one I was going for before. Enceladus itself is an icy moon just like we had Europa. Enceladus, however, doesn't have that magnetic field interaction, and we have a little bit more details because of Cassini. Cassini was a craft around Saturn. Its mission was ended, and it got to have a very cool ending. We purposefully went into the atmosphere of Saturn to have it ripped apart. Yay. It told us a little bit about the atmosphere. But Enceladus here has another icy, solid surface. There's no atmosphere. There's no anything outside the ice. It also has cracks along its surface, which means tectonic activity. And, of course, we've seen water spewing out of it. However, we got to see more kind of specific details. We actually got pictures of this water. And when we took chemical samples of it, it was extremely salt water,
It had the chemicals that we were looking for, specifically the chemicals from hydrothermal vents. If you ever watch a nature documentary about the bottom of the ocean, they're going to show you a hydrothermal vent. It's that thing in the bottom of the ocean that spews out a whole bunch of dust. It's produced heat, it's produced chemicals that would make life. The only thing we would need to have life on this moon is effectively lightning. There's no atmosphere, which causes a problem, but ice produces friction when pushed against each other. It's possible there could be microcellular life on this moon, though we don't know. As for life that isn't like the Earth, we go to another moon around Saturn, the largest moon in our stellar system, bigger than Mercury by a pretty good margin. This is Titan, a titan of a moon. It was named pretty obvious. Titan itself is one of the very few moons to have an actual atmosphere. It's big enough to contain an atmosphere. It means it's big enough to hold on to its chemical elements, unlike Mars was able to do. Mars was unable to do that. Titan itself, though, is so different that astrobiologists talk about the possibilities, but it's much more vague of the already vague astrobiology terms they use. This atmosphere is murky, it's brown, it's gross. What it is effectively methane and methane, the backwash from your car, gasoline. And, well, there's a gasoline atmosphere. Not something human life could breathe, not something any life on our world can breathe. However, when we look underneath its atmosphere is when we get hope, because there's these areas, these dark areas with radar that we see that have kind of oceanic regions. So there's rivers underneath this atmosphere. These rivers, these lakes are make Titan the only other object in the known solar system to have liquid lakes on its surface, not completely encased by something. The Earth is the other one with water. But these lakes are also made up of methane and ethane. Astrobiologists kind of talk about this idea. Methane is extremely combustible. It is an extremely useful fuel. We still use it to power our cars today. Biological life, simple-celled organisms have evolved on the Earth to use methane as power, and it is a very good source of power. So it's possible that underneath these oceans there could be biological life that runs like our engines. Kind of. But we don't know, because we don't know if amino acids could exist in an environment so corrosive. Oh well. But those are the three best places to look for life. Jupiter is not the best, but Saturn's definitely got a few things going for it. But with that being said, I just looked at the clock and oh my goodness. So I'm out of time. If you have any further questions for me, anything you'd like to ask about space science, please feel free to come by and talk with me. I'd love to give you any information that I can. Please do remember to double check your space as you leave. Head down the stairs following the arrows out the entrance. Please remember there's probably an audience waiting because, I'm over time. And so as you leave, open those doors slowly so you don't hurt yourself or others. Please remember this 2 o'clock show changes each and every day based on audience questions, based on things that they